Here are the solutions to the exercises in Chapter 6. Here's my solution to the very first exercise, the one involving searching for the word foo. Let's go through it. Well, the very first thing I do is I don't need to do this, but I set the pattern right at the top of the file so it's clear and obvious for people to find. If you need to search for a different pattern, it's quite easy to change the program. You just change it once at the very top. Then of course I have to set a size of 0. That will be what I accumulate my sizes into that variable, and it's vitally important that I initialize it to something. EXPR will have trouble with that if I don't. And now I use a simple for loop for f in star, so I examine every file in the current directory. Now some of them may be directories, so the very first thing that I actually have to check is that the file that I'm checking is a regular file. If it's not, then I simply continue. Now that line is not absolutely necessary. I could leave it out, and what would happen is if grep in the next line ever encountered a directory, then it would give us an error message, which would mean that I'd have to also redirect the standard error of grep to dev null as well. But I put that in for kind of neatness. I don't really like errors very much, and I'd also like to demonstrate the use of the word continue. So if we make it to the next line, which is here, then we must be working with regular files. It might actually be useful at some point to test whether the file is readable, but I'm going to assume that they all are. Now the easiest way to test whether a given file contains a given string of text is to use grep. And to save the actual results being displayed on the screen, then I simply redirect the output to /dev/null. Grep will return true or 0 if you like, if the file does contain the pattern that we're looking for. So if we do happen to find a file that contains the pattern, then we have to next obtain the size of the file. Now there are probably a couple of ways of doing that. The way I chose to do it is to cat the file and pipe the results wc -c. The -c option for wc counts the number of characters. So I enclose all of that in backwards quotes and assign that to a variable called size. And then next it's a very simple matter to use EXPR to add that size to the existing total and put the result back into total. So we're doing quite a few things here. We're using a for loop, we're using a continue statement, we're using EXPR, and we're using some other general clever techniques like redirecting grep output to dev null, using wc -c to obtain the size of a file, and so on. So let's see if it actually works. Let's do an ls-l in this directory, and we'll find that we actually have 4 files in this directory. Some of them will hopefully contain foo. I'm guessing that the foo loop program itself actually contains the word foo. So let's run it. Foo loop. Total size of all files containing foo is 800. Now I can tell you just off the top of my head that the file abc does contain the word foo, and contacts does not, and names.dat does not. So abc and foo loop were the only files that contained foo, and their sizes, as you can see, were 576 and 224, which indeed add up to 800. So the program seems to be working. Let's try it in a directory that does not contain the word foo, like the parent directory here. So we'll do chapo6 /foo loop. So run the foo loop program from the chapter 6 directory in this directory, and we get the total size is 0. So I'm guessing that that is in fact correct. Now let's have a look at the course project. So here we are in the contacts program, the course project. We'll notice here that the main addition is the adding of this line here, while true. Well, I often find that the simplest thing to actually do in a loop is create what I call a forever loop, which just loops and loops and loops, and somewhere inside the loop we can put a terminating condition, or we can continue, or whatever. As I demonstrate the rest of this sample solution, you'll see that this is actually a reasonably neat way of doing it, and I'm not saying that if you did it another way, using the regular sort of while input does not equal q technique is not a good way of doing it. That way usually works perfectly fine as well. It's just that I've chosen to show you the forever loop, because it is a useful technique to occasionally resort to. Anyway, let's move on and have a look. All of this stuff is pretty much as before, display the menu, but now we actually, rather than just prompting them for an answer, we prompt them for an answer and we say, or Q to quit. And then we read the answer and process it as normally. But I'd like to do some special handling with empty answers. If they just press enter and don't type anything at all, then we'll just redisplay the menu, and it will be like they never typed anything at all. I'll show you that in a second. So we'll just continue if they type nothing, and then do the case statement as before, and 2 and 3 and 4 all the same, but with the Q, and I've noticed that I've used Q star or Q star, capital Q star, because I want any line that begins with a lowercase or uppercase q to be counted as a Q to quit. I've actually covered all the bases there. Then we simply exit the program. Exit 0. 0 is our exit status, which is essentially a no error exit status. And then of course the other condition, please enter a number between 1 and 4, and we move on. Now finally, right at the bottom of the loop, because I clear the screen every time around the loop, I actually want to give them an opportunity to see the output of the option that they've chosen. So I just say hit enter to continue, and then read their enter. And of course, as soon as they read chunk, we go immediately back to the top of the loop and continue the loop, which will of course redisplay the menu. So let's see if it works. If I went through that too quickly, don't worry, because I've included this solution as usual on the CD for you to examine at your leisure. Let's now examine the solution working. And so let's first test the case where I type in nothing at all. I just press enter. Now you probably didn't even see that flicker, but I have pressed enter a couple of times so far, and it's just going right back around the loop again. Let's type in an invalid answer. Type in some rubbish. Please enter a number between 1 and 4 and press enter to continue. And around we go again. And I might type 5 this time again. An error message. Maybe one of the options is not implemented yet. The search case is not implemented. Fine. Press enter to continue. So how about one that we have implemented? Now, create records. Please enter the following contact details. Now I'll just enter some rubbish here. And notice I get the hit enter to continue again. And now I'm still back in the loop, ready to do more things like create another record or view a record. So let's do the view records selection. And here are the current contacts in the database, blah blah blah, there is one, and hit enter to continue. And around we go around the loop again. Okay, and so everything seems to be working, so I can now test to see whether we can exit the program by typing Q, and that worked as well. Excellent. So there is again a sample working solution to the specification of the problem.